micturition, and blood pressure and volume. We're going to begin by looking at the micturition reflex. Stretch receptors in the bladder are stimulated in order to begin micturition. Impulses are then sent to the spinal cord. Parasympathetic impulses contract the urinary bladder and relax the internal urethral sphincter. As the bladder contracts, you get the urge more and more to go to the bathroom because it's, again, causing more stretch on that organ. The impulses are also sent to the brain and then back to the external urethral sphincter, telling the external urethral sphincter to relax. As a result, you will urinate. We also have to look at how the kidneys can maintain the blood volume and therefore blood pressure. If our stimulus is an increase in blood solute concentration, the hypothalamus causes ADH, or antidiuretic hormone, to be released from the posterior pituitary. ADH causes the collecting ducts to become more permeable to water. As a result, water is able to be reabsorbed into the bloodstream. Additionally, the hypothalamus causes you to be thirsty so that you go and take in more water externally. As a result of both of these processes, the blood volume increases. The hypothalamus then decreases the release of ADH, and our negative feedback system has stopped. Taking a look at this picture, it's just the same thing in pictorial form. Our blood solute concentration had increased. The hypothalamus then causes you to be thirsty and causes the posterior pituitary to increase the release of ADH. In the kidneys, ADH causes the collecting ducts to become more permeable to water, thus allowing the body to reabsorb more water. That would then increase the amount of water inside the bloodstream, bringing us back to a normal blood solute concentration, thus a negative feedback system. Diuretics, these are chemicals that are going to inhibit the release of ADH in the body. If ADH is not present, the collecting ducts are not permeable to water, and as a result, water is lost in the urine. Examples of diuretics that you may come in contact with in everyday life are things like caffeine and alcohol. So if you've ever been out drinking, let's say one evening, you may have noticed that you would urinate much more frequently than if you hadn't been drinking alcohol, and that, of course, is because alcohol inhibits the release of antidiuretic hormone. Aldosterone also plays a role here. Aldosterone is a steroid from the adrenal glands. What aldosterone does is it increases the sodium reabsorption in the kidney tubules. So if you increase more sodium, you're going to increase the reabsorption of chloride, because chloride, of course, follows sodium due to charge attraction. And now that we've got sodium chloride being reabsorbed, we're also going to have water being reabsorbed via osmosis. This will ultimately increase the blood volume and blood pressure. There's also some more hormonal control of blood volume. If we have a stimulus that is a drop in blood volume or blood pressure, there are some cells in the kidney called the juxtaglomerular apparatus. They will release a hormone called renin. Renin converts a plasma protein that's inside the blood at all times called angiotensinogen into angiotensin 1. Please don't let that word intimidate you. Angio refers to blood vessel, tensin refers to tension. Ogen simply means that it's a precursor molecule. So when angiotensinogen gets converted to angiotensin 1, then we have angiotensin 1 getting converted to angiotensin 2. That happens in the presence of angiotensin converting enzyme, or ACE. Angiotensin 2 then is a vasoconstrictor. that causes the release of aldosterone. So now, in addition to having a vasoconstrictor, which will increase your blood pressure, we're also going to release aldosterone, which we now know causes the reabsorption of sodium, which will cause the reabsorption of water, increasing blood volume and blood pressure. As a result, our system has moved opposite our stimulus. Again, a negative feedback system. This picture just shows you the juxtaglomerular apparatus where our renin is going to be released from. And there are some additional kidney functions. One is to regulate acid or hydrogen ion concentration inside the bloodstream. Hydrogen ions can be removed from the body in urine. When they are, of course, the concentration of hydrogen ions is going to decrease, and as a result, the pH would go from being acidic closer to a neutral situation. So this process is actually buffered by sulfates and phosphates because then we would have a really acidic urine if we didn't have a buffer involved. Hydrogen also binds with ammonia, and it becomes ammonium. That's one way in order to bind up that hydrogen ion and increase the pH of the system. Ammonium then is excreted in the urine. Kidneys also are going to have the ability to stimulate red blood cell production. Believe it or not, the kidneys recognize low oxygen levels and they secrete a hormone called erythropoietin. Erythropoietin then travels to the red bone marrow and it causes more red blood cells to be produced. Another function of the kidney is that it can activate vitamin D, which we know is needed for calcium absorption. Disorders of the urinary system. You will be responsible for the disorders of the urinary system in the textbook on an exam or quiz. They are located on pages 366 to 367. As always, if you have questions or concerns, please let me know, and I would be more than happy to help you with those.